Welcome, welcome. So good to see you. Make yourself comfortable because today we're exploring a fascinating intersection of language and 3D technology. We're diving into the groundbreaking research paper titled LLaMA-Mesh, Unifying 3D Mesh Generation with Language Models, a collaborative effort from the brilliant minds at Tsinghua University and NVIDIA. Now, imagine being able to describe a 300D object in plain language and have a model generate its mesh instantly. That's precisely what LLaMA-Mesh achieves by leveraging large language models, or LLMs, traditionally known for their prowess in understanding and generating text. This innovative approach taps into the spatial knowledge embedded within these models, knowledge gleaned from vast textual sources like 3D tutorials. One of the standout challenges tackled by LLaMA-Mesh is the tokenization of 3D mesh data. Typically, language models handle discrete tokens of text, but 3D meshes are inherently spatial and complex. The solution? Representing vertex coordinates and face definitions of 3D meshes as plain text using the OBJ file format. By doing so, LLaMA-Mesh seamlessly integrates 3D data without the need to expand the model's vocabulary, maintaining the integrity and efficiency of the original language model. To build this capability, the researchers curated a supervised fine-tuning dataset comprising 31,000 meshes from the Objaverse dataset. Each mesh is meticulously converted to the OBJ format with vertex coordinates quantized into 64 bins to streamline processing without significantly sacrificing geometric detail. This dataset not only includes text mesh pairs, but also interleaved dialogues that enable conversational 3D generation and mesh understanding. Training such a sophisticated model isn't a trivial feat. LLaMA-Mesh was fine-tuned on 32 A100 GPUs over 21,000 iterations, a process that took approximately 3 days. The result? A model that can generate high-quality 3D meshes from textual prompts, produce interleaved text and mesh outputs in conversational settings, and interpret and describe meshes with impressive accuracy. But what does this mean in practical terms? For one, the quality of mesh generation rivals that of models specifically trained from scratch on 3D data. Moreover, LLaMA-Mesh maintains strong text generation performance, ensuring that its language capabilities remain robust even as it branches into the 3D domain. This dual functionality opens up new vistas in fields like computer graphics, engineering, robotics, and virtual or augmented reality, where intuitive and efficient workflows driven by language-based instructions can revolutionize content creation. The experiments conducted showcased not only the diversity of generated meshes, but also the model's ability to preserve its conversational abilities post-fine-tuning. For instance, when given the same text prompt multiple times, LLaMA-Mesh produced a variety of unique meshes, each satisfying the prompt in its own distinct way. This level of creativity and variability is crucial for applications requiring multiple design options or variations. However, like any pioneering work, there are limitations to address. The quantization of vertex coordinates into 64 bins, while effective, does introduce some loss of geometric detail. Additionally, the current context length of 8,000 tokens limits the complexity of the 3D structures that can be generated. The model also caps the meshes at 500 faces, which, while manageable, restricts the level of detail available in more intricate designs. Looking ahead, the researchers suggest several avenues for future work. enhancing the encoding schemes for 3D data, extending context lengths, and improving geometric precision are all on the horizon. Moreover, integrating additional modalities such as textures or physical properties and expanding the model to handle dynamic scenes could further elevate the capabilities of LLaMA-Mesh. In conclusion, LLaMA-Mesh represents a significant leap towards unifying multimodal content generation within a single language model. By bridging the gap between text and 3D mesh generation, this research not only broadens the functional scope of large language models, but also paves the way for more intuitive and versatile tools in 3D content creation. As we continue to explore and refine these integrations, the potential applications seem limitless, from interactive design and virtual reality to education and manufacturing. Thank you for joining me today on this exploration of LLaMA-Mesh. It's an exciting time in the world of AI and 3D technology, and I can't wait to see where these innovations take us next. Until next time, keep curious and stay inspired.